One of the most important skills that we will learn throughout this course is how to carry out these types of unit conversions and calculations as accurately as possible, because it's really an important skill in practical life. An example for how catastrophic this could be when you make a small mistakes in these conversions is what happened in one of the space flights, and it was like a $125 million spacecraft that was sent to Mars, but the scientists made a very small mistake that led to a very big impact, which actually caused the spacecraft to enter Mars atmosphere 100 kilometers lower than it's supposed to be. Very naive mistake about assuming that mass is the same as weight, and that's not correct. Mass isn't weight. And he did all the calculations assuming that a mass of 1 pound equals a weight of 1 Newton. This is not correct at all. In fact, 1 pound has a weight of 4.45 newtons. So that mistake in a calculation led to that significant catastrophic impact at the end. So we'll learn how to do these calculations and unit conversions accurately in this course, and we'll do a lot of these types of calculations. It doesn't matter what units you are using in unit conversions, you will set up all of these unit conversions in a very similar way. In general, whether you're doing this unit conversion based on a random conversion factor or based on the SI prefixes conversion factor, it's going to be the same setup. You will have two orientations for the conversion factor. For example, if you're converting a meter to an inch, you either have 1 meter per 39.37 inches or the opposite. So the opposite arrangement is the same. Which one you will use is going to be the given unit in the bottom and the desired unit on top. You take 69.5 inches. The conversion factor that you will use has to have inches, the given quantity in the bottom, and meter, the desired quantity on top, so that when you carry out the calculation, it's going to cancel out inches with inches and leaves you with the desired quantity. So it's going to be 39.37 inches for each 1 meter. So again, we'll use a calculator and you will type 69.5 times 1 divided by 39.37. So it's going to equal 1.76 meters. Using SI prefixes is even much simpler because, as we said, you need to memorize these conversion factors, but let's have them up for us to do some of these examples for now, but you need to memorize those. And all what you need to do is simply replace the symbol for the SI prefix with the corresponding conversion factor. 6.01 grams, and you want to convert it to kilograms. So you will multiply it times the conversion factor that has grams in the bottom and kilograms on top. Usually you will have 1 for the unit that has the SI prefix, and the conversion factor will be associated to the base unit. So a kilogram corresponds to 10 to the power 3 grams. So when we carry out the calculation, it's going to cancel grams with grams, and it's going to give you a number in kilograms. So it's going to be, again, 6.01 divided by 10 to the power 3, which is the same thing as multiplying it times 10 to negative 3, whichever way you want to do it. So let's divide it by 1,000. So that's gonna be 6.01 times 10 to negative 3 of a kilogram. These types of unit conversion calculations, as I said, are really essential for our class, and it proves more useful when you deal with derived units for properties like density. So density is mass per unit volume for the sample. So it will have a derived unit of the unit of mass divided by the unit of volume. So for solids, that's gonna equal 1,000 kilogram per cubic meter. But luckily, we can kind of simplify this unit to a more simple unit, because 1,000 kilograms per 1 cubic meter, and you use the SI prefixes to simplify this. This is gonna equal 10 to the power 3 times 10 to the power 3 of a gram. That's the translation of kilo from the SI prefixes, divided by 10 to 6 cubic centimeter. So it's actually, you can cancel out these two numbers with each other. So it's actually equivalent to 1 gram per cubic centimeter. And for solutions, it's more commonly used to express densities in grams per liter. Density is one of the most important properties and units in general chemistry, because it's actually characteristic for different substances. Once you are able to measure the density, you should be able to come to a conclusion about the identity of your substance. So if you have a 100 milliliter graduated cylinder containing 60 mils of water, and you put 3 marbles with that total mass right here into the water, and this is the new reading that you see in this case. What is the average density of marbles? So we start by listing the information that we were given in the problem statement. The initial volume of the water equals 60 milliliters. The 100 milliliters size of the graduated cylinder has no use for us in this case. Okay, so the mass of the marbles equals 95.2 grams. Okay, so if we go back to look at the definition of density, density equals mass divided by volume for the subject. We have the mass, which is given right here, but we don't have the volume. The volume is going to actually equal the initial volume, the final volume of the water after the marbles were added, minus the initial volume that is given right here. So we have to read the final volume from the picture in front of us. So if you look at this picture, typically when you read volumes, you read it from the bottom of the liquid curve. So you can see that you are certain that the level is above 76. So V2 is gonna equal 76 milliliters, but it's actually a little bit above 76. So you have to estimate that number. So we'll estimate it to be 0.1. You cannot estimate any further, and it doesn't actually make any sense to try to put any effort to estimate any further, because it's not going to be accurate at all. So you have to stop at the first uncertain number in your estimation. So that's milliliter. So the volume of the marbles is gonna be equal to 76.1 milliliter minus the initial volume, which was 60.0 milliliter, which means it actually equals 16.1 milliliter. Now that we have the volume, we can conveniently calculate the density, because it's going to equal the mass of the marbles that were given in the statement, which is 95.2 grams, divided by the volume that we calculated, which is 16.1 milliliters. So it's going to equal, again, 95.2 divided by 16.1, so it's gonna equal 5.91 grams per milliliter. So with that calculated density, we can answer the second part of the question, which asks about the mass of a single piece of marble with that density, given that the volume equals 7.8 milliliters. Density equals mass divided by volume, so that means that the mass is gonna equal density times volume. So the mass of our piece of marble is gonna equal the density that we calculated. It's 5.91 gram per milliliter divided multiplied by the volume, which is 7.8 milliliters. So multiply this times 7.8, and this is going to give us the mass of 46.1 grams.